Hello students. So today we are going to learn the chapter integration. So everyone knows that integration is of two types in our textbook. That is, first chapter it is dealing with indefinite integrals and second one it is definite integrals. Okay. So in this session we are first going to study about indefinite integrals. So before going into that, let us ask you what is meant by integration. What is the meaning of integration? We always use this word in the whole chapters. So what it really does? Like why are we using integration? Why are we studying it? So that is a big question. So in order to understand that, I will make a quick details. I will give you a quick details about what is the meaning of integration. So integration is nothing but its another word is summation, that is adding. If you have lot of small areas, how will you find the area combining all of them together? We will just add it, or add each small areas, you will get the final area. So that process, that summation, is the another word for integration. Nothing but it's a kind of addition. Okay, but here we are using different techniques to add. That's it, not like normal adding. Okay, so in this particular chapter we are going to find the you are going to find how to do, or how to find the integrals of certain functions. Okay, so before that, let me just make you understand how we use integration to find the areas, or what is the use in our daily lives. So we know two-dimensional figures like rectangles, squares and circles that are there. So here I am drawing one rectangle, then this is a circle. So these all are two-dimensional figures. So how will you find the area of such two-dimensional figures? It is very easy. Okay, circle means this is the area covered by this particular circle, and here we have a rectangle. So this rectangle has a length, has a breadth. Then area is very easy to find, length into breadth. If you take this circle, that area will be pi r square. That is also very easy to find because we already have the equation to find the area. Now, how will you find the area of a curved surface? That is, for example, instead of this rectangle, what if we have a figure like this? Like, instead of straight lines, what if we have a curved surface? So here I am simply drawing one example, like if this surface is like this, how will you find the area of this particular figure? It is very difficult to find because this is not a rectangle, here it is curved. So in such conditions we utilize the use of integration. So I will explain in a very simple way, like if I am drawing one graph like x-axis, this is x-axis and this is y-axis, and let the curve be like this, something, any curve. Okay, so we have to find the area under this particular curve. I'm giving some limit, like from x-axis I'm putting two values, this is a and this is b. Okay, so we have to find the area under this particular curve. How will you find this area? That is from here to here. We cannot find in any manual ways because this is a curve. It has a curved surface and this is not any two-dimensional figure. We don't have an equation. So in such cases, what we do is we divide this area, whichever area we want to find, we divide that in the form of any kind of two-dimensional figures that we already know. For example, here I can divide it into rectangles, very small rectangles like this. It won't be like accurate because this is a curved side. So we are dividing it into very small rectangles. As the number of rectangle increases, the accuracy also increases. So I am again dividing it into rectangles. Like that, just to divide this complete region into small rectangles. So then find the area of each rectangle and add it. That is the basic thing. But in integration, it's not like you have to find each area and add. Just to take one, that small strip, whatever area we are taking, then integrate that with respect to the function, then you will get the area under the curve. So this is the basic application of integration, which you will study in detail in the coming chapter, that is the application of integrals and all. So here we are just I'm just explaining like why we are studying integration and what is its use, why we are studying it, so that what is the main application. Okay, so this is a very good application, like integration can be utilized for all these purposes. So now let us go back to our problem solving part. Indefinite integrals, we are going to learn how to find the integrals of certain functions. So for that, one definition is very important. Other than summation or anything, this is the very important definition. So this definition states that integration is nothing but the reverse process of differentiation. This is very important. Reverse process of differentiation. So it is very easy to understand also. Like if you have a function and if you find the derivative of the function, whatever derivative, and if you are integrating the derivative, you will get the function back. Like no need to confuse, let us see a simple example. Like I am writing here one example, f of x is equal to x square. This is a function. Okay, so now I am finding the derivative of this function f dash x, that we all know it is 2x. We already learned about how to find the derivative. So we got the derivative. Now what I am doing is I am integrating this derivative, integral of 2x dx. So how will you find integration? This is very one of the easy basic way. Integral of x raised to n dx is equal to x raised to n plus 1 divided by n plus 1 plus c. This is the equation. So here we know 2x, and if any constant is there, you can take it outside. So 2 is a constant, I am taking it outside. So 2 into x dx. So here 2 into, so here you can see this is x raised to 1. Integral of x raised to n is x raised to n plus 1 by n plus 1 plus c. So 2 into x raised to 1 plus 1 divided by 1 plus 1 plus c. Like this you will get. Then x raised to 1 plus 1 is x square. So 2 into x square by 2 plus c. 2 and 2 we can cancel. So we will get x square plus c as the answer. So one more thing is that whenever we are doing the integration of any function, we should always put an arbitrary constant c, because this constant, derivative of the constant is always 0, right? A constant doesn't have a derivative. When you do the differentiation, it will automatically cancels, it will become 0. So in integration, we don't know whether any constant was present there before. That is, instead of the function x square, if I am writing x square plus 2, what is the derivative? D by dx of x square plus 2. That is again 2 derivative is 0. So again it will come like d by dx of x square only. That is the same thing. You will get 2x, right? So if any constant is there, we will never know like if it was there or not. So just for safety, we will put one c, just to show that if any constant was there, it can be c. That is why we are always putting arbitrary constant after integration, because when you again do the differentiation, you will get the same function back. So here you can see this x square plus c, x square is nothing but it is the function f of x. So In this, I can simply write like this: integral of f dash x dx, derivative, then you will get the function back, f of x plus c. So this is the basic understanding of what is an integration. If you have a function f of x, if you find the derivative of the function, then that derivative, if you integrate, then you will get the function back. That's it. Okay, so now let us go back to some properties for doing the integration. But before that, let me solve one more example based on this idea of differentiation and integration. So I am writing one question: integral of cos x dx. How will you find its integral? So here our question is cos x. So we have to go back and think which function, when you differentiate, you will get cos x. That is our answer. Very simple. You want to find the integral of cos x, means which function, when you differentiate, you will get cos x. Okay, that function will be the answer. Answer is very easy, right? D by dx of sin x is what? D by dx of sin x is cos x, right? Derivative of sin x is cos x. So if you integrate cos x, what you will get? We will get sin x plus c. So it is nothing but sin x plus c. You have to put a c also. That is the answer. Second question. Then third one, I am writing the next question: integral of sin x dx. So here we are finding the integral just by using that basic concept of differentiation. So this also you can find that way. But one small consideration should be required in this case: sin x dx. Okay, so which function, when you differentiate, you will get sin x? Answer is what? Cos x, right? D by dx of cos x. That, but one thing is there, the derivative of cos x is what? Minus sin x, right? There is a negative sign, but here we don't have a negative sign, so whatever is the answer, you should put a negative sign, minus cos x plus c. This is the answer. So when you you can check it, no, just to differentiate minus cos x, d by dx of minus cos x. Cos x differentiation is what? Minus of sin x. So minus of minus sin x, you will get plus sin x. So that's it. Which function, when you differentiate, you will get sin x. That is our answer. So our answer is minus cos x plus c. Negative is coming because derivative of cos x is minus sin x. Here minus is not there, so we have to put here. That's it. So now let us go back to some basic properties. These properties are very simple yet very important also. So you can write it properties. In that, first property is, first one, integral of f of x plus g of x dx equal to dash. So here we can see that under this curly brackets, inside this curly brackets, we have f of x plus g of x. So in order to find the integration, we can separate them. That is, you can write integral of f of x dx plus integral of g of x dx. This is the first property. Okay. So one example I will write. Example, you have to find the integral of x square plus 1 dx. So how can we separate integral of x square dx plus integral of 1 dx? So integral of x square, find it, x cube by 3 plus 1, it is x. So like that you will get the answer. So here I am just explaining how to separate them. Okay, so this is one property. Then next property is integral of k into f of x dx. K can be any real number. Then we can take it outside. K into integral of f of x dx, where k can be any real number. K can be any real number. So these two properties are very simple also and very important also. So any questions we can use it. Okay, so now let us do one question regarding integration, a simple question. Integral of tan square dx, tan square x dx. This you have to find. So how will you find this integral of tan square x dx? So you have to think back again our definition. Which function when you differentiate you will get tan square x? Is there any function that when you differentiate you are getting tan square x? No, tan square x is not the derivative of any of the function. So when such equation comes, we have to change it. That is, we have to make some changes in the question so that we can integrate it. We know the identity sec square x minus tan square x is equal to 1. So how can you write tan square x? Tan square x is equal to sec square x minus 1. So you can use this identity to find the integration because we don't have any function whose derivative is tan square x. Okay, so I'm just changing this integration like this. Integral of, instead of tan square x you can write sec square x minus 1 into minus 1 dx. Now again here we can see we can separate it, right? Our first property, this you can separate of integral sec square x dx minus integral of 1 dx. Now check which function when you differentiate you will get sec square x. Yes, tan x. D by dx of tan x is what? Sec square x. So this answer will be tan x and minus integral of 1 dx. Which function when you find the derivative you will get 1? Of course x. D by dx of x is what? 1 only. So this is x plus c is very important. Just put it there. So this is our answer. Very simple. Okay. So one more question we will try. Next one. Integral of 1 plus sin x whole divided by cos square x dx. This is the question. Integral of 1 plus sin x divided by cos square x dx. See, for such questions, when you are finding it difficult to do what to do next, you can clearly see the addition sign in the numerator. Like for example, if I am writing a function like 1 plus x by 2, I can really separate it 1 by 2 plus x by 2. That is same as 1 plus x by 2, right? So here cos square x is the common denominator for both 1 and sin x. So first step you should do is separate this so that you will get some idea about how to proceed further. Plus here sin x by cos square x dx. Like this, just separate them. Now what is 1 by cos square x? 1 by cos square x is sec square. Sec square is a very positive thing for us because we can directly write what is the integral sec square x dx? Tan x, because derivative of tan x is sec square x. Plus, now here you can see sin x by cos square x. How can you write this? Sin x divided by cos square x means cos x into cos x. Okay. Now this you can write it. This is sin x by cos x into 1 by cos x. What is sin x by cos x? Tan x. What is 1 by cos x? Sec x. So this you can write it as, or else you can just write, you can directly writing in the same order. Sin x by cos x. Okay, 1 by cos x is sec x. Sin x by cos x is tan x. So you will get this as sec x tan x dx. Now we can separate them. this you can write it as integral of sec square x dx plus integral of sec x tan x dx. It is very easy now. Sec square x, what is the integral? Which function when you differentiate you will get sec square x? Answer is very simple, tan x. Plus, which function when you differentiate you will get sec x tan x? Yes, derivative of sec x. D by dx of sec x is sec x tan x. So, the integral of sec x tan x is nothing but sec x plus c, which is always a must. So, this is the answer. Okay, so these are all basic integration, very simple questions. Like only we are using basic identities that we have said, separation, then separating denominator, converting it into some things, some other familiar equations, so that we can find the integration. Okay, so this is it regarding this particular question. Now we will move to the next part, that is integration by substitution, the last part of this session. So integration by substitution. Substitution meaning itself, we know that we are substituting one of the thing into another, like substitution. So here this method is actually easy to find the integration of some functions that we are not able to find in the normal way. Okay, I will write one simple example for you. Like we can start with an example itself, then it will be more clear. Integral of cos x divided by 3 plus sin x dx. Here you can see we can't split the numerator, we can't think of any derivative, nothing like that. So how will you find the integration of this particular function? So here we have to focus on one thing, that is substituting. Which one we can substitute? So it is very easy to check, like we have a numerator, we have a denominator. So numerator if you find the derivative, what you will get? Derivative of cos x is minus sin x, not applicable. So we will take the denominator. Here our denominator is 3 plus sin x. So I am just substituting, like you can provide any variable or of your own, but here I am just writing it as t. Let us take t as 3 plus sin x. This is called a substitution. We are substituting 3 plus sin x as t. Now take the derivative on both the sides with respect to x. Then here you will get dt by dx. Then here d by dx of derivative of this complete function 3 plus sin x. Okay. Now dt by dx is written here, right? Then here we have d by dx of 3 plus sin x. We can separate it. D by dx of 3 plus d by dx of sin x. But we know that constant, the derivative is 0. So you will get dt by dx is equal to, this is 0 plus, then derivative of sin x is cos x. So we got the result like this, dt by dx is equal to cos x. Now let us go back to the question. In our question we have a numerator cos x. Our numerator is cos x dx. So take dx to here. dt is equal to cos x dx. Okay, right? So here we got the substitution. One substitution is this, that is instead of cos x dx we can just put dt. Another substitution is this one, the first one that we wrote, that is t. T as 3 plus sin x. So just to substitute that in the question, instead of this cos x dx we can write it as dt, and instead of 3 plus sin x we can write it as t. That is it. That is integral of 1 by t dt. The question will change into this. Now check. 1 by t dt, which function when you find the derivative you will get 1 by t? Yes, answer is very simple, log of t, log t. If I am deriving it with, I am finding the derivative with respect to t, d by dt of log t is what? 1 by t. So when you integrate 1 by t, what you should get it? Log t. It is very easy, d by dx of log x. D by dx of log x is what? 1 by x. So that only we are using it here. So we will get integral of 1 by t dt is equal to log t plus c. Whenever you are using a log function in an integration, always you should use the modulus symbol. Why? Why are we using modulus symbol? Because anything comes inside this log, it should be positive. It should not be 0. It should not be negative. It should always be greater than 0. That is why we are putting the modulus function to show that it is positive. Okay, that's it. Or if it is not positive, we are taking only the modulus, so that the logarithmic function exists for that. So this is our final answer, but our answer t is which one? T, we gave substitution 3 plus sin x, so that you can replace here. Our answer will be log 3 plus sin x plus c. This is the final answer. So in the substitution method or any question comes for integration, you don't have to do all these process if you just focus on one thing. Just when you get a question, just to see, okay, just to see if this question's denominator and numerator has any relation. For example, in this particular question, numerator is cos x, denominator is 3 plus sin x. So just to check, whenever you get a question, just check if the denominator, that is if you find the derivative of the denominator, you are getting numerator or not. Here our denominator is 3 plus sin x. But when you find the derivative, what is the derivative of 3 plus sin x? D by dx of 3 plus sin x. D by dx of 3 is 0. D by dx of sin x is cos x. So when you find the derivative, this constant derivative will become 0. Only sin x is the derivative of sin x is cos x, which is the numerator. So whenever in any question, if you have a denominator and a numerator, and the denominator, when you find the derivative of the denominator and you are getting the numerator, you don't have to do all these steps. You can directly write the answer as, that is integral of cos x divided by 3 plus sin x dx. Numerator is the derivative of denominator. So directly you can write the answer like this. Log modulus of denominator plus c. This will be the answer. You don't have to do anything else. Only one condition you have to check, that if numerator is the derivative of denominator, then derivative of denominator then integration you can write it as integral is log modulus of denominator plus c. This is very simple technique, very easy also. No need to do any substitution in this case. If directly you are getting like this, just write the answer as log modulus of denominator plus c. That is the answer. This is the shortcut. This is a trick which you can apply in entrance exams or anywhere if such condition exists. So that's it for today's session. So thank you everyone. I hope you all got some idea about integration. So thank you very much.